session. In the last video, we have talked about the motion of charged particle in a magnetic field. Okay, in this session we are going to derive equation for the motion of a charged particle in a magnetic field. So what formula that we follow for the charged particle moving in a magnetic field is like QV cross B. Right? Q is the charge in coulomb of a particle which is moving in the magnetic field. V is the velocity of the particle, of charged particle, and B is the magnetic field. Here I have denoted B with a cross. It means you have a magnetic field which is penetrating your screen perpendicularly to your screen, is going inside your skin, right? Means direction of B is like it's going inside, directly penetrating into your skin, right? That's what this notation says, right? And we have a charged particle which is entering by velocity v, with velocity v from outside. Okay, then what will happen? It will experience some force. First we need to find out what is the angle between this velocity vector and this magnetic vector. Magnetic vector is right inside the screen, and V is there in the surface of the screen, right? V is in screen surface, and magnetic vector is perpendicular to the surface. It means the angle between V and B is 90 degree always, because V will be there here only in the surface, and magnetic fields are perpendicular to the surface. Means angle between V and B will always be 90. It means QVB sine 90 degree, means QBV, and the direction of this is the direction perpendicular to this surface, perpendicular to the F and surface, right? So what would be the direction of force? Would be 90 degree to the velocity and 90 degree to the B vector. 90 degree to the B vector and velocity means the F vector will be there in the surface, but it will make 90 degree to velocity vector. It means this one, everywhere at any point the force vector will always be 90 degree to the velocity vector, right? And the magnitude of force will be given by QBV. Means here you have a QBV, here we have QBV. In the circular motion concept, we have learned that if some force is acting toward the center, the same force is acting toward the center, then that particle will follow the circular path. Or in other words, if some body or some particle is following a circular path, so there must be some force which is which would be toward the center, and that force called centripetal force. It means here the magnetic force is acting as a centripetal force. And what is the formula for centripetal force? F is equal to mv square by r. If r is the radius, let's assume this r is the radius. If r is the radius and m is the mass of this particle q, charged particle q, and v is the velocity, then the centripetal force will be given by mv square by r, and this should be equal to QBV, right? It means the radius of the circle, right? It will form a circular path, and the radius of that circular path will be mv by QB. mv by QB. This is very important formula, and you already know what is the meaning of mv. What is mv? Mv is the momentum. Mv is the momentum, means radius of the circular path would be p by qb. This means the radius of circular path is proportional to p, means If particle will have very high momentum, the radius would be very large and is inversely proportional to q and b. This is very important formula to remember. Okay, and then because it will follow the circular motion, it means it will follow kind of SHM path, simple harmonic motion. Then we have to have some time period, and time period generally given by what, 2 pi by omega, right? It's 2 pi by omega. Then time period, we'll calculate time period now. V by r, what is value of V by r? V by r will be q by m. It means omega will be equal to qb by m, because omega is equal to V by r, V is equal to r omega. You know omega now. Time period will be 2 pi by omega. Okay, it means t will be equal to 2 pi m by qb. This is the period, 2 pi m by qb. Here one more stuff which we can think of, like we can formulate this one in terms of kinetic energy also. If k is a kinetic energy, then 2 km would be your momentum by qb. Means if any problem, if kinetic energy is given and qb and m are given, you can find out the radius of the circular path of a particle moving into the magnetic field, 90 degree to the magnetic field. Okay, these are the simple formulae which we have derived using the fundamental formula qb cross b. Okay, now you can do some problem based on this, and if you find any questions, do ask me. Okay, see you in the next lecture. Bye.